Hello, everyone. Today, I want us to look at the measure of central tendency and together with the analysis of it. So we have different ways in which we do central tendency. So now that we have learned how to calculate the measure of central tendency, so I just want us to go through it again, and then we bring in the box and whisker plot, and then we do the analysis interpretation. Okay, which is part of the data analysis. Okay, so one of the things that we need to understand here is the first question says calculate the median of the data set. So if you remember with the median, you always look at the concept of arranging the numbers from the smallest to the biggest. So in this case, the number have already been ordered from the smallest to the biggest. Okay, so in this case, what we do is now we're just going to focus on the concept of looking at the numbers as they are. Okay, so the middle number here is the 60 and the 61. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And same thing there all the way that side. So what we're going to do there, we're just going to say 60 plus 61, and then we divide this by 2, and then we get our answer there, which is going to be 60, 5. Okay, and that becomes our median there, which is going to be found area. Okay, then let's proceed. Okay, and then as we proceed there, you will see that everything becomes simpler and easier when you start following this particular concept of how you do the numbers. Okay, so the next question here says calculate the mean. Calculate the mean. Okay, and in terms of calculating the mean, what we do, this one is simpler. We formula sum of scores divided by the total number of scores, and then which means we're going to add all those numbers there, and then after adding all those numbers, we divide them by the total number of scores. In this case, is 20, and then which we get 1,231 out of 20, and then we get our answer there, which is 61.5. Okay, and this becomes easier in terms of how we understand this. Okay, which is 61.5 there, as you can see. Okay, and that's how we get our answer. Okay, now let's move on in this particular context. So you will also understand this particular concept in terms of that all these numbers mean something, and as we go, we will be able to interpret all these numbers. So based on your results above, which measure between the median or the mean better represents the performance of the class? Explain your reasoning. So in this case, one can say the mean is better or the median is better, but because they are very close together, we can say they are more or less similar, right? But in this case, we know that the mean is affected by the extreme or by the outliers. So as a result, the median is always better because it's not affected by the outliers, especially because they are closer together. Okay, and that's what we look at. So the next question says here, find the outlier. So we found the lower quartile and the upper quartile. So if you remember, we got our numbers here in terms of when we were doing the calculation, right? Our median was between 61 and 62, which means the median was somewhere here, which was that 60.5. So now we're going to look at the numbers on the right and the numbers on the left. And actually, if I look at these 10 numbers here, you can see that I've got 54 and 56. And this side, I'm going to have 65 and 66 as my middle number. So it's 1, 2, 3, 4, and same thing, 1, 2, 3, 4. So in this case, it will be 65 plus 66 divided by 2, and this will give me 65.5, and that's my upper outlier, and my lower outlier there, it will be 54 plus 56 divide by 2, and then my answer there is 55, and this is my lower outlier. Okay, so you will see that this just becomes easier because of the fact that we have the even numbers in our left and the even numbers in the right. So the two middle number, we add them and we divide them by 2. Then compute the interquartile range. If you remember the interquartile range, we use the formula IQR is equals to Q3 minus Q1. And we did find out that our Q3 was 65.55, and then minus 55, which was our Q1. And then the answer that we get there will be 10.5. Okay. And that's our interquartile range, which is the middle 50%. Okay. Now, the question here says use the IQR to determine the lower and upper boundaries for outliers and identify any outliers in the data set, if any. So to get the boundaries, if you remember, you have the Q1, okay, minus 1,5 times IQR. You remember that this is a formula, right? And then Q1, we know that it's 55 there. Then we subtract 1,5 multiplied by 10,5. So from here, you just use a calculator, and then you're going to get 39.25. And this is our boundary for the lower boundary, for the lower outlier, for the lower quartile, sorry. And then now we're going to have Q3 plus 1,5 times IQR. And also this is a formula. So then we know that Q3 in this case is equal to 65,55. And then in this case, then we add the 1,5 multiplied by 10,5. And then we're going to get the answer of 81,25. Okay, so in this case, we know now that any number less than 39.25 is an outlier, and any number above 81.25 is an outlier. So in this case, the only number that was above, if you look at this, the number that is above 81 there, it's 100 only. So the 100 will be our outlier, okay? So then draw a box and whisker plot highlighting the 5-number summary. In this case, we're going to the outlier. Okay. So the first one, we know that we have a 45 as our minimum, right? And then our lower outlier there, if you remember, we had so not the lower outlier, the lower quartile. Okay. We had 55. So 55 is going to be here. Okay. And then our median, if you remember, it was 60.5. So just a slightly above the 60 there. And then our maximum, so our upper quartile, we got 65.5. So 65.5 is also going to be somewhere here, just slightly above there. Then we have our box there, as you can see. And then from there to there. So our outlier, our maximum now will be 73. And then we're going to have a dotted line there that goes to 100, which was our maximum, which is 100. And this shows the outlier. That's why we're saying that our new maximum will be 73. And then this is just showing us the dotted line to go to the maximum. Okay. And then you remember you need to label this. So this is minimum. And then this is Q1, then Q2, and then Q3. Then you can say marks here, and then outlier. Okay, and that's how it goes. Okay, now let's move on. Is the distribution symmetric, positively skewed, or negatively skewed? Justify your answer using the shape of the box and whisker plot. So if you look at the box of the whisker plot here, what we normally do, the box of the whisker plot, we look at the box. The box is just this part here in between here, right? And we look at the distance between the median and the upper quartile and the median and the lower quartile. Okay. If you look at this distance by means of subtracting the Q3 from the median and the Q1 and the Q2 from the Q1 there, you will understand that the distance there is very close. Okay. So because it's very close, then we can make a claim that it's approximately symmetric, right? But one can also say no, it's positively because the other side also have a little bit more. So one can say this of 5 is still bigger, so it is positively skewed, which is still acceptable. But by means of looking with an eye there, because this is also affected by the fact that we have an outlier, you can say that this is moderately close because of the fact that um, the, 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 the the distance between the two is very close when you look at the box itself. Okay. Secondly, when you do the comparison between the mean and the median, you remember that the rule says that if the mean is greater than the median, then it is positively skewed. So in this case, we can then say no, the distribution is positively skewed because the mean is greater than the median. So, but this, remember that it includes the 100%, the 100 score, which is the outlier, and this pulls the average up. So based on how you look at it and how you want the data to say, both of these two answers can be acceptable as long as they are being backed up by the data. Okay. So in 3 to 4 sentences, summarize what the box plot of your calculation tell us about the learner's performance in the class. So this one is very simple in a sense that we look at the middle 50%, right? So the middle 50% tell us that half of the class scored between 55 and 65, right? Which is our middle 50%. And then we have 25% who are in their lows, and it's only between from 40 up until 55. And then we look at the ones who go to high, the upper 25%, which is up until 73%. Okay. And that can tell us a lot in terms of how we can talk about the performance of the learners. And also looking at the median, it means that half of the class got 60% and above. So that also is one of the things that we can mention there. And then we must mention the skewness of the data, that the data is slightly skewed, or you can also say it's approximately symmetrical, suggesting that learners performed well in a sense that they maintained the bell curve. Okay. Now, lastly, is the concept of the standard deviation. The teacher claims that most of the learners performed close to the average based on the standard deviation as 11,5. Comment on whether you agree or disagree with this claim. So I will say here 11,5 is a bit high for a standard deviation. Remember that the closer the standard the smaller the standard deviation, the more clustered the data is around the mean. And then the 11,5 is considered to be a little bit high in a sense that it's a bit more compared to the mean. So in this case, we can say no, the presence of the extreme score, such as the maximum there, which is the outlier, it's pulling the average up. And because it's pulling the average up, so some scores are a little bit far away from the mean. And as a result, then we can also say that no, the statement that the teacher is giving is not correct because the standard deviation is very high. Okay. And this is how you look at it. So this is just an example of how you can answer questions and analyze the data. Okay. If you have any question, don't hesitate to send me an email. Thank you so much.